Hello, this is Jen, your instructor. I received several emails from students asking for help with this week's homework, which was calculations for enteral and parenteral formulas. So I thought I'd do this little video to demonstrate how to do some of those calculations. So we're going to start with the enteral formula. And the question had asked you to select two formulas from the back of the book, tables G1 and G2, and calculate the nutrition value of those formulas and how much formula you would need to deliver to the patient to make sure their nutrient needs were met. So the first thing you need to do is turn back to that chart at the back of your book. It's Appendix G. And select one of the formulas. I'm using Nutren 2.0, so please do not choose that formula for your calculations. Choose a different one, please. But the methods are going to be the same. The chart provides the same information for all of the formulas. So if you follow along with me, and you look at Nutren 2.0 in the Appendix G1, you'll see that it says you need 750 milliliters to meet 100% of the DRI, that it has 2 calories per milliliter, and that it provides 80 grams of protein per liter, 196 grams of carbohydrate per liter, and 104 grams of fat per liter. So take a moment now to look at that chart and just make sure you see where I'm getting that information and make sure you see what that information would be for the formula that you are using. So once you have sort of jotted that information down for yourself, the next thing that you're going to do is to calculate the amount of formula that you need to deliver 1,750 calories, which is the amount that they list in the question. Each patient that you would have would require a different amount of calories, so you'd have different calculations for each patient. But for this problem, it's asking you to calculate for a patient who needs 1,750 calories. Now, this calculation is very simple. For a lot of the formulas, they provide 1 calorie per milliliter. So if you needed 1,750 calories, you would need 1,750 milliliters. Some of the formulas provide more calories than that per milliliter. And in that case, you need to divide the calories by the calories per milliliter. So for example, with the Nutren, it's 1,750 calories divided by 2 calories per milliliter gives you a volume of 875 milliliters. Yours may be different, obviously, because you're using a different formula. Like I said, many of them are 1 calorie per milliliter, and then it's just very simple. It's just that's how many milliliters you need is the same as the number of calories. Others are 1.5 or something different. All you need to do is divide the calories by the calories per milliliter, and that will give you the milliliters that you need. Moving on. The next thing you need to figure out is how much carbohydrate, protein, and fat does that provide. It's important that you know that 875 milliliters is the same as 0.875 liters. Your calculations are going to be different, but you need to be able to move that decimal point over to convert milliliters to liters, because the measurements for the grams of protein, carbohydrate, and fat are given per liter. So since I am giving less than 1 liter of the formula, the patient is going to get less than 1 liter's worth of the protein, carbohydrate, and fat. So referring back to that chart where it said, for example, Nutren provides 80 grams of protein per liter, I'm not giving a whole liter of formula. I'm giving 0.875 liters. So I need to multiply 0.875 liters times 80 grams of protein. That equals 70 grams of protein. So for your examples, if you end up giving, for example, say you were using a 1-calorie formula and you ended up giving 1.75 liters of formula, your amount here is going to be greater than the grams of protein in 1 liter because you're giving more than 1 liter of formula. So bottom line, take the amount of formula that you're giving, make sure you convert it to liters, and then multiply the amount of liters you're giving times the grams of the nutrient per liter. So for mine, it's 0.875 times 80 grams of protein is equal to 70 grams of protein. 0.875 liters times 196 grams of carbohydrate is equal to 171.5 grams of carbohydrate. And lastly, 0.875 liters times 104 grams of fat per liter is 91 grams of fat. Again, you get this information from the chart, so make sure that you're using this information for the specific formula that you are using, not for Nutren, which is what I'm using. Okay, so now we know how many grams of protein, carbohydrate, and fat are provided in the amount of formula that you are going to be giving this patient. Now, the next step is important to realize why you're doing the next step, because when I look at these numbers, even as someone who's worked with nutrition for a long time, and I think 91 grams of fat, is that a lot? Is it a little? I have no idea. What do I compare that to? It's a lot for, say, an infant, but it's not a lot for a 20-year-old man. So we need some sort of guidance to tell us, is this a lot of protein, a lot of fat, a little fat? And where that comes into play is the percent of calories from protein, carbohydrate, and fat. So if you remember on your diet analysis projects, those little bar graphs that showed you of all of the calories in your diet, how many came from protein, how many came from carbohydrate, how many came from fat. It's a measure of the mix of nutrients in your diet. And there are very specific guidelines for that apply to a 12-year-old girl who weighs 86 pounds and a 20-year-old, I was going to say quarter pounder, but that's not the right word. Football player, quarterback, someone who needs a lot more nutrition, they're still going to need the same sort of mix of nutrients, even if they need lesser or fewer calories total. So back to our example. We know how many grams of protein, carbohydrate, and fat our formula is going to provide because we just calculated that. Now we want to know, what blend of nutrients does that represent? What percent of the calories are coming from each of those? And it's not straightforward because, as you know, protein has 4 calories per gram, carbohydrates have 4 calories per gram, and fat has 9 calories per gram. So you need to do a little math here to get the ball rolling on these calculations. So the first thing you're going to do is say we have 70 grams of protein times 4 calories per gram, 280 calories from protein. Same with carbohydrate, times 4 calories per gram. Same with fat, times 9 calories per gram. Now we know how many calories come from each nutrient, but we still don't have a good sense of what proportion is that. What we need to do is compare it to the total calories. So that's the second half of this calculation. That's the second half of this calculation. So we say for protein, if 280 of the calories of the total came from protein, that's 16%. For carbohydrate, 686 of the calories came from carbohydrate compared to the total, that's 39%. And with fat, so you're dividing, you're taking 819, which we calculated up here, 819 calories from fat compared to the total amount of calories. So divided by the total calories, 1,750, and that should equal 47. Your example obviously will be different. Now remember a couple different things. In your calculation, just remember to be using your figures, not the figures I'm using here in this example. An important point here, if you look at these percentages, 16% of calories from protein, that comes out about right. That's about the recommendation for protein. Usually we say 10 to 20% of calories from protein. However, right here, this is a bit low. Normally, we recommend about 50% of calories from carbohydrates for people and then about 30% of calories from fat. Maybe a little less calories from carbohydrate, a little more or less from fat. But what you can see here is that these two figures, the carbohydrates are low and the fat is high compared to recommendations. What you need to realize is those recommendations are for normal, healthy individuals, but this is a person who is getting a tube feeding, who needs a concentrated formula. That tells you right there that they're not just the average person walking down the street, that they have some specialized health needs. And so for their particular situation, this might be an appropriate recommendation for a mix of carbohydrates, fats, and proteins. For my example, I'm using a formula that is 2 calories per gram. 2 calories per milliliter. That's a calorically dense formula. That is saying this is a patient who needs a lot of calories delivered in a small volume. So obviously, in order to sort of pack that formula with calories, the fat needs to be increased. So don't be alarmed if these numbers don't look right to you. For most of the formulas in table G1, they will come out to be about what you expect to see as a mix of nutrients, but some of them are a little higher or lower in 1 calorie, depending on the patient's specific needs. What you do want to check is a couple things. This is a good point to check your math, is that these numbers should total 100%. So 16 plus 39 plus 47, in my example, actually comes out to 102%, but close enough. You don't want something that says, 150% or 40%. The total should be fairly close to 100% because 100% of the calories have to come from one of these 3 things. These are the things that provide calories. They're going to only come from protein, carbohydrate, and fat. So these totaled up must equal 100% because that's the only place you can get calories from. Another way to check your math is to make sure that these 3 numbers, 280, 686, and 819, total up to roughly the total number of calories. So if you add these together, they're going to roughly equal 1,750. Or for your calculations, whichever numbers you used. Okay, so that is how you answer that first part of the question. To number 1, figure out how much formula you need to provide. In my case, it was 1,700 to provide 1,750 calories. And then also how much protein, carbohydrate, and fat would your patient obtain from this formula and what percent of the calories that represents. The last part of the question is, does this volume of formula meet the RDIs? Now, this is very simple. You don't have to do any math at all. You just need to look at the chart. And for my example, the chart said I needed 750 milliliters of formula, it's that first column, to be 100% of the RDI. So if you give that amount of formula, it has all the vitamins and minerals that you need, at least at 100%. Because I am giving 875 milliliters, that's more than the amount needed to provide 100%. So I can rest assured that my patient will be receiving at least 100% of the RDI for vitamins and minerals. Okay. Moving on to the second question, calculating average daily energy intake provided by a TPN solution. Oh, I just wanted to say, remember that it is asking you to do the calculations for question 1 for 2 formulas. So make sure you pick one from G1 and G2. It's really good practice to just to do those. Besides following along with my video, this is also covered in the text in the how-to box in your chapter. Let me see if I can quickly flip through the book and see what the box is. That tells you how to do it. Box 15.6 in your textbook starts you off on those calculations. Okay, so moving on to the TPN. So for this question, I am just going to give you guys a run through of the actual question. I'm not using a different example. So if you're one of the brilliant people who decided to watch this video, your reward is that I'm doing the actual problem for you. So you can just follow along. Please write it out for your homework and let me see that you followed along. But I'm going to be doing the actual example given in the question. Okay, so for that question, it said, this patient gets 2 liters per day of a TPN solution, and each liter contains 500 milliliters of a 50% dextrose solution and 500 milliliters of a 5% amino acid solution. Please note, 500 plus 500, that's 1,000 milliliters, that's 1 liter. But they get 2 liters of this per day. So the first part is asking us to calculate the average daily energy intake just from this solution. Then the second part of the question adds some fat in, but we're going to do that after this first calculation. Okay, so remember, the problem says 2 liters of solution, but gives the amounts in 1 liter of solution. You must remember to double at the end of the calculation. Okay, so the one fact that you need to know to do these problems is to understand the notation. What does 50% dextrose solution means? What that means is 50 grams, so a 50% dextrose solution would provide 50 grams of dextrose monohydrate per 100 milliliters. This is box 5-12 in your text. If it was a 40% dextrose solution, it would provide 40 grams of dextrose. If it was a 25% dextrose solution, it would provide 25 grams of dextrose per 100 milliliters. But we're not giving 100 milliliters, we're giving 500 milliliters, which is 5 times as much. So we need to multiply 5 times the 50 grams that are provided in the solution for a total of 2,500 grams of dextrose monohydrate in that 500 milliliters. The next thing that you need to know to be able to do these calculations is that dextrose monohydrate is not the same thing as pure glucose. It is a sugar, obviously. The OSE should let you know that it's a sugar. Monohydrate means that there is one water molecule attached to that dextrose molecule. So if you think about it this way, some of the space of that molecule is being taken up with water, which is no calories. So that's why it's lower in calories than pure glucose, because some of it is water, actually bonded onto the molecule. So for TPN solutions that use dextrose monohydrate, which most of them do, you are going to use 3.4 calories per gram compared to the normal 4 calories per gram that you normally would for nutrition calculations. Okay, so we determined that in this 500 milliliters of solution, we're getting 250 grams of dextrose. So 250 times 3.4 calories per gram is a total of 850 calories from that 500 milliliters of dextrose. So the calculation for amino acids is very similar. Again, just a reminder that this is saying that they get 2 liters of solution, so we're going to need to double at the end. All right, so amino acids, same thing. 5% amino acid solution means there are 5 grams of amino acids per 100 milliliters. Since you're giving 5 times that much, you're giving 500 milliliters, multiply times 5. That's 25 grams of amino acids. Amino acids are just straightforward, just like you're used to. It's a protein, so 4 calories per gram. So 25 grams of amino acids times 4 calories per gram, that's 100 calories of amino acids from that 500 milliliter solution. Okay, now you're going to add up to get your daily total. So in 500 milliliters of the dextrose, there's 850 calories. In 500 milliliters of the amino acids, there's 100 calories. So combined, that provides 950 calories in 1 liter of solution. Remember, this 500 plus this 500 is equal to 1,000 milliliters. 1,000 milliliters equals 1 liter. So in that 1 liter of solution, that's the dextrose and amino acids, they are getting 950 calories. Remember, oh goodness, look at my spelling mistake. Remember that this patient receives 2 liters per day. So 1 liter was 950 calories times 2 liters is they are getting 1,900 calories per day from their TPN solution. Now, so that is just from the first part of the problem, the dextrose and amino acids. But the second part of the question says, how many calories would they be getting per week if, daily, average daily, if they also get a 500 milliliter of a 20% fat emulsion 3 times per week? It makes it a little more complicated because it's not every day. If it was every day, you could just add that onto the daily calories. But since it's 3 times per week, we're going to calculate it out per week and then divide by 7 to get the amount per day. Okay. What you need to know to understand the calories in a lipid emulsion. Excuse me, I have to yawn. Oh, excuse me, I'm so sorry. Okay, so for fat emulsions, lipid emulsions, box 513 in your text states, 20% fat emulsion means that for 500 milliliters, there are 2 calories per milliliter, totaling 1,000 calories. So 500 milliliters times 2 calories is 1,000 calories. 10% fat emulsion means for 500, there's 1 calorie per milliliter, so it would be just 500 calories. But we're not worried about that because the problem states 20% fat emulsion, and this is just what it is. 500 milliliters of emulsion, 2 calories per milliliter, 1,000 calories. These typically come in like a pre-portioned bag for the right amount, so that's why they don't have a lot of variable in the and a lot of need to do out those calculations because they're usually typically done. So there's usually either a 10% emulsion that's 500 calories or a 20% emulsion that's 1,000 calories, and it's easy. You don't need to do any calculations. You just plug in either 500 or 1,000 calories. Moving on, so now we need to add up everything. So this patient we determined was getting 1,900 calories from their TPN solution. That was the calculations that we just did. They're getting those every day for 7 days. So 1,900 times 7 days is 13,300 calories in the whole week. 3 times a week, they're getting that 1,000 calories from the fat emulsion. So that adds 3,000 calories. The total calories they get per week from all sources is 16,300 calories. You're going to divide that by 7 days to get the average calories per day, which gives us our triumphant final answer of 2,329 calories per day. If you followed along, like, good for you. Please write it all out and do the calculations yourself. And, you know, if you're a big nutrition nerd like me, what you might do is to fool around with the numbers a little bit. See what it would be like if you were using a 10% fat emulsion instead of the 20%. Or what would the calories be if you were using a 40% dextrose solution? You could do that for fun in your spare time, I'm sure. But as far as homework this week is concerned, please write out the calculations. There is a value to even just sort of following along and writing them out like that. And if you have any questions or you need help, please let me know. I'm extending the deadline for this assignment to midnight on Sunday, so you can work on it a little extra and it won't be late. And just text me or call me if you have any problems. It's noontime on Friday, and I'm about to sign off my computer for the weekend. So I won't get a message from you if you email me, but I will get a message from you if you text or call. Thanks for watching the video, and good luck with the homework.